Using your quotient rule, I know my quotient rule is f prime g minus fg prime, square the bottom, and away you go. So again, f is your numerator, which is tangent of x. So if my numerator if my f is tangent of x, what is f prime going to be? Secant squared x. G is the denominator of x plus 1. What is g prime? G prime is going to be what? 1. So now substitute into my quotient rule. So f prime is secant squared times g, which is x plus 1, minus f, which is tangent of x, times g prime, which is a 1. All over your denominator squared, so that would be your x plus 1 to the second. So when I clean this up, I'll end up with secant squared of x times x plus 1 minus tangent of x all over x plus 1 to the second. Now, the thing that you have to be on the lookout for when you are dealing with these problems involving trig functions, there's lots of different ways you can express the answer correctly. This answers can take on several different appearances. So when you're taking multiple choice tests and you're taking multiple choice quizzes, this answer may not be there. Or when you're checking your answers tonight, your answer may not be there. What they may try and do to you, and they will, is they may substitute in all kinds of Pythagorean identities that we've studied. So for example, if we take a look at secant squared x, I can rewrite secant squared x as 1 over cosine squared x times x plus 1 minus, I can change tangent into sine x over cosine x all over x plus 1 to the second. This is a complex fraction that they're going to simplify on you. What would you multiply everything by? You'd multiply everything by what to simplify it? Cosine squared. So then I'm going to be left with x plus 1 minus sine x cosine x all over x plus 1 to the second times cosine squared x. What you have to recognize is that my original answer and these two answers are equivalent. They are equivalent. So if this is a multiple choice test, you may not see this written as an answer choice. So you may see this as an answer choice. But what you have to do is be able to manipulate them using all your different theorems and all your different identities that we've studied. They are equivalent answers. Certainly if it's a free response question, I would accept that. But the where they get you is, again, like I said, if it's a multiple choice question, just be on the lookout for this. So any questions on number 2? Take a look at 3, sine of pi over 4. What rule am I going to have to use on this one? Well, what is the sine of pi over 4? What is the sine of pi over 4? Square root of 2 over 2. So what kind of square root of 2 over 2 is just a what? It's just a constant. And the derivative of any constant is 0. So the answer number 3 is just 0. Let's take a look at number 4. X to the third sine x. What operation is happening between your x to the third and sine of x? Multiplication. So what rule are we going to use to differentiate this? What rule are we going to have to use? Product. So you have to use your figgy, f prime g plus fg prime. So f is my first function of x to the third. So what is the derivative of x to the third? The derivative of x to the third is 3x squared. My g is sine x. So what is my g prime then? G prime is going to be the cosine of x. So now I need to plug and substitute into my product rule. So f prime we identified as 3x squared times g, which is sine of x. F is my x to the third times g prime, which is a cosine of x. Get used to these more complex derivatives being put into factored form to clean them up. What common factor can you factor out of this entire thing? You can factor out a what? What's in common in both terms? You can pull out a what? x squared. So I factor out an x squared. That's going to leave me with a 3 sine x plus x cosine of x. That's how most of your answers are going to be expressed, especially when we get to the exponential functions, when we talk about derivatives of exponential functions. So any questions on 4? You guys go ahead and try number 5 for me on your own. Again, taking the derivative of x squared is just your power rule. What rule are we going to have to use to differentiate 2x cosine x? We're going to have to use the what? What rule do we have to use for 2x cosine x? It's another product. It's another product. So go ahead and try number 5 on your own.